Hey everyone, welcome back. Today we're doing a deep dive on LLMs,
Large language models.
right? But more specifically,
Yeah.
we're looking at a new research paper about their architecture.
Uh-huh.
It's a fascinating paper because it suggests that,
Ah,
it suggests that there are these single parameters that
what?
they're calling superweights,
Yes.
and that these superweights have like a huge impact
Or
on the way that LLMs work.
oh yeah, for sure.
It's almost like, you're debugging a massive code base.
Uh-huh.
And you find this one line of code,
Yeah.
and if you just change it even a little bit,
Oh
the whole
yeah.
program just crashes. That's
That
kind of what we're talking about here.
yeah, so this paper really highlights how important these superweights are.
So it says here that if you just get rid of one of these superweights,
Mm-hmm.
it can basically turn the LLM into like a gibberish machine.
It can, I mean, you're absolutely right.
That's kind of freaky to think about, right?
It is pretty wild. It's like
Yeah.
this tiny little change.
And
Yeah.
have this massive cascading effect.
And as software engineers,
Yeah,
that should be particularly interesting to us.
absolutely, because it shows just how sensitive these complex systems can be.
Right. And it makes you think about all the potential points of failure.
For sure, for sure. But it's also super exciting because it gives us new insights into how LLMs work.
Okay, so we've talked about these superweights
Yeah.
and how important they are, but
Yeah,
the paper also mentions outliers.
right.
Are those the same thing?
That's a great question.
Yeah.
So we've known about outliers and LLMs for a while now,
Okay.
but superweights are kind of a different beast.
How so?
Well, they're like a tiny subset of these outliers,
Okay.
but they have like this outsized influence.
So not all outliers are superweights,
Exactly.
but all superweights are outliers.
Exactly.
Gotcha. So then where are these superweights? Like, where do they live in the model?
So they tend to be found in this thing called the MLP.downprod weight matrix.
MLP. Yeah. And specifically in the early layers of the LLM.
Okay, hold on.
Yeah.
For those of us who, haven't been like dissecting LLM architecture,
Sure.
what does that even mean?
So basically imagine an LLM is like this big neural network
Mhm.
with all these layers processing information.
Okay.
And this MLP.downproj thing,
Mm-hmm.
it's part of a mechanism in those early layers
Okay.
that seems to be super important for how the LLM understands language.
So that's where these superweights are hanging out,
Yeah, pretty much.
influencing everything from their little hiding spot.
You got it.
Okay, but how did the researchers even find these superweights?
Good question.
It's like looking for a needle in a haystack.
Yeah, with billions of needles.
Billions of parameters.
It's crazy. So they didn't actually use like traditional data-driven methods.
Oh, really?
Yeah, they did something much cooler.
Okay.
They dug deep into the model's internal workings and analyzed activation patterns,
Right.
looking for any unusual spikes.
So it's kind of like,
It's kind of like you're trying to find a faulty wire in a huge circuit,
okay.
and you're looking for where the current suddenly surges.
Interesting.
Right.
They were like digital detectives following the trail.
Exactly.
The paper calls them super activations.
That's right.
So I'm guessing
Yeah.
super activations are related to superweights.
You got it. The superweights are actually what cause these super activations.
So you have this one superweight,
Yeah.
and it triggers this cascade of super activations
That's
that
right.
ripples through the whole model.
It's a chain reaction, basically.
And then that affects the output.
It affects what words the LLM is likely to generate.
Now, what I find really interesting is that
Yeah.
the paper says these super activations are involved in suppressing stop words.
Right, like the A and.
Yeah, exactly. So why would these powerful activations target something so basic?
Well, stop words are important for grammar,
Sure.
but they don't really carry much meaning on their own. It's like these super activations are telling the LLM,
Okay.
hey, don't just generate stop words, focus on the more meaningful stuff.
So the superweights are like the gatekeepers of meaning,
I like that.
keeping the LLM from getting lost in all the filler words.
It's a cool way to think about it.
Okay, but how does this relate to something like LLM compression?
Ah, great question.
Because that's a big deal for us software engineers, right?
Absolutely, especially when we're trying to get these massive models
Right.
to run on devices with limited resources.
Exactly.
Yeah.
So how do superweights play into that?
Well, traditional compression methods,
Gets hip.
they often struggle with outliers.
Like superweights.
Exactly, because compressing them can really mess up the model's accuracy.
So how do we deal with these superweights during compression? Do we just avoid compressing them?
We could, but there's actually a more clever way.
Oh.
Yeah, it's called holdout and restore quantization.
Oh.
Huh. It's actually pretty simple. You identify the superweight,
Uh-huh.
and you protect it from being compressed.
So it stays intact.
Exactly. While the other parameters go through the regular compression process.
That makes sense.
Yeah.
So what are the advantages of this approach?
Well, you can shrink the model down significantly
Okay.
without losing much accuracy.
That's awesome.
It is. And it's a huge win for software engineers.
Especially when we're working with limited resources.
Exactly.
This is fascinating stuff.
Yeah.
So we've learned about these superweights and how they can completely disrupt an LLM
Yeah.
if they're removed. And we've talked about how understanding them can lead to better compression techniques.
Right.
Which is super relevant for us software engineers.
Absolutely.
But we've only just scratched the surface here.
Oh, yeah. There's so much more to explore.
So stay tuned, and we'll be back after a short break.
To dive even deeper into the world of superweights.
We'll be exploring how they challenge our understanding of LLM architecture.
And what they mean for the future of AI development. It really is amazing how these superweights challenge how we used to think about LLMs. Like, we always thought of them as these big networks where everything was kind of spread out evenly.
Right, like everything was equally important.
But now with these superweights, it's like there's a control room where a few levers control the whole thing.
Yeah, and that has huge EE implications for how we develop and optimize these things.
Absolutely. Imagine if we could just tweak a few of these superweights instead of retraining the entire model.
That would save so much time and resources.
Oh, yeah, for sure. And it could make them safer, too.
Oh, how so?
Well, if we can find the superweights that cause problems, like bias or generating harmful content, we might be able to just adjust those.
Without messing up the whole model.
Exactly.
That's amazing.
It is. It's still early days, though.
Right. We're just starting to understand these things.
Yeah, we've got a lot more to learn.
Okay, so before we get too far ahead of ourselves, can you give us a concrete example of how these superweights actually affect an LLM's output?
Okay, so let's say you're using an LLM to generate text, and you give it a prompt, like the cat sat on the... Now, a well-trained LLM, with all its superweights intact, it would probably predict mat or chair next.
Makes sense.
But if you remove the superweight, things get weird. It might just keep generating the... Yeah, like the cat sat on the...
So it gets stuck.
It does. It's like it loses its ability to tell the difference between important words and just filler words.
So the superweight is like a filter.
Yeah.
Making sure the output is actually meaningful.
Exactly. It keeps the LLM from just spitting out random words.
That makes sense. And it has huge implications for how we train these things.
Oh, yeah. If we can figure out how to identify and use these superweights better, we could really improve LLM performance.
Speaking of improvement, you mentioned earlier that understanding superweights can help with quantization. We talked about holdout and restore before, but can you explain that a bit more for our software engineer audience?
Sure. So traditional quantization methods, they don't always handle outliers well.
Like superweights.
Right, because when you compress them, you can lose accuracy.
But with holdout and restore.
Exactly. With this method, you basically protect the superweight.
So it doesn't get compressed.
Right. It stays the same while you compress everything else.
So you're basically giving the superweight special treatment.
You could say that.
And that leads to better results.
It does. You get smaller models without sacrificing accuracy.
That's amazing. Especially when we're trying to run these models on devices with limited resources.
Exactly. It opens up a whole new world of possibilities.
Like LLMs on our phones.
Maybe someday.
But before we get carried away,
Yeah.
let's go back to these super activations.
Okay.
We know they're connected to superweights. But what's actually going on there?
So super activations are basically these really large values that pop up in the neural network.
And they're caused by the superweights.
Exactly. The superweight acts like an amplifier, boosting certain signals.
So creating these massive spikes.
Yeah, and those spikes don't just disappear.
Oh, really?
They actually stick around.
Interesting. So they have a lasting effect on the model.
They do, and that's partly because of how LLMs are structured.
How so?
Well, LLMs have these things called skip connections.
Oh, yeah, I remember those.
They're like shortcuts in the network.
Like express lanes on a highway.
Exactly. They allow information to bypass certain layers.
And those skip connections help spread those super activations around.
That's right. They help them persist across different layers.
So the superweight triggers the super activation.
Yeah.
And then the skip connections spread it throughout the model.
You got it. It's a fascinating system.
It really is. So we've got the superweight, which triggers the super activation.
Right.
And the skip connections deliver it.
And all of that works together to make sure the LLM generates coherent text.
It's amazing how much complexity is hidden inside these models.
It really is. And we're just scratching the surface.
I think my brain is full for now.
I hear you.
We've covered a lot of ground today.
We have, from superweights
to superactivations.
And everything in between.
It's clear that these tiny parameters are playing a huge role in the world of LLMs.
Absolutely.
But let's take a short break to digest all this.
Sounds good.
And we'll be back in a moment to wrap things up.
Looking forward to it.
Okay, so we're back. And we've been talking all about these superweights in LLMs.
These super important parameters.
Right, and it's crazy to think that just one of these things can have such a big impact.
Oh, yeah. It really changes how we think about these models.
Right. It's not just about the number of parameters anymore.
Exactly.
It's about how they're connected.
And which ones have the most influence.
So it's like we've discovered this hidden hierarchy inside LLMs.
A secret control panel.
And that opens up
so many possibilities.
Right, like imagine if we could just fine-tune these superweights.
Instead of retraining the whole model.
Exactly. That would be a huge time saver.
And it could help with safety and bias, too.
Oh, yeah, for sure.
Yeah.
If we can identify the superweights that are causing problems.
Right. We might be able to just tweak those directly.
And avoid those undesirable outputs.
That's really exciting.
It is. It's like having a scalpel instead of a sledgehammer.
But we're still early in the game, right?
Oh, yeah. We're just starting to unravel the mysteries of these superweights.
So what are some of the big questions that researchers are trying to answer?
Like, how did these superweights even emerge?
Yeah, like what makes them
during training
so special?
Right? Can we predict which parameters will become superweights?
And if we could, could we engineer them? That's the dream, right? To build LLMs that are more efficient and controllable.
By designing the superweights from the start.
Exactly.
Yeah.
And we also need to understand
how they work with other parts of the model.
Yeah, like the skip connections.
Right. How do those two things interact?
It's a whole new level of complexity.
It really is. It's like we zoomed in on this one tiny thing and this whole universe opened up.
That's science for you. It's all about discovery.
Well, I think it's safe to say that we've all learned a lot today.
About these mysterious superweights.
So for our software engineer listeners who want to put this knowledge into practice, what are some of the key takeaways?
I think the biggest one is that not all parameters are equal.
Right. Some are more super than others.
Exactly. We need to understand the architecture and how everything fits together.
And for practical applications. Understanding superweights can lead to better compression techniques.
Like hold out and restore quantization.
Which is great for running LLMs on devices with limited resources.
Exactly. It's a game changer for sure.
This has been an incredible deep dive.
It has. We've learned so much.
It's mind-blowing to think that something so small can have such a big impact.
It makes you wonder what else is out there.
Right. What other secrets are these LLMs hiding?
Only time will tell.
Well, thanks for joining us on this journey.
It's been a pleasure.
We hope you've enjoyed this deep dive into the world of superweights.
And their impact on the future of LLMs.
Until next time, keep exploring and keep pushing the boundaries of technology.